In this video, I'm going to show you my tool process hunting toolkit and how it can be used for malware analysis. I released this tool a few months back, and you can download the tool from IntelliRoot GitHub repository. Now let me show you a demonstration of the tool. So I would be using Ramcos rat as a malware, and then I'm going to execute it and run the tools in the system and show how the tools can be used to analyze the malware. So the toolkit has three tools. One of them is process anomaly scanner. Next is process memory scanner, and third one is injected code hunter. I'm going to run the malware and after that show you how to use these. So I have an instance of Ramcos rat malware, and now let me execute this malware. So I have executed Ramcos rat, and here is the instance of Ramcos rat running in the system. And also you would see that here is a SVC host which is created by this Ramcos rat. So most likely this SVC host is a hollowed process, which is a child of this Ramcos rat. Now my turn to execute the tools. So before executing the tools, remember the tools should be executed in administrator mode. So uh, remember to launch your command prompt in administrator mode and then execute the tools. Now let me show you how process anomaly scanner works. So process anomaly scanner identify the anomalous behavior of the processes. For an example, based on the process tree and parent-child relationship, it can detect some of the malicious process. For an example, the parent of SVC host should always be services.exe. But here, if you see, SVC host is a child of Ramcos rat. So here is a process tree of the system where you can see all the SVC hosts are children of services.exe, and similarly there are other processes which have this parent-child relationship. So as of now, it detects some of the anomalous behavior based on the parent-child relationship. Now let me execute uh, the anomaly scanner. So here, if you see, I have executed the anomaly scanner, and here it is detecting this particular SVC host based on parent-child relationship. Its PID is 1384. So here is the 1384 is the PID, and this one is the suspicious SVC host. Also, apart from this, it detects some other behavior. For an example, uh, it checks for the number of instances of system processes. For an example, uh, in your system, ideally there should be one instance of explorer.exe and two instances of cssrs.exe, and there can be many instances of SVC host. So based on the number of instances, some of the malwares can be detected. Apart from that, if any of the system processes are running from app data path, then it can be also treated as suspicious. So anomaly scanner checks for all these anomalies. Now, the next tool in the toolkit we are going to execute is process memory scanner. Now, this process memory scanner relies on a signature file with name scan.dat, and it should be placed in the same folder where procmem scanner is there. And again, it should be run in administrator mode. So process memory scanner scans the virtual memory for processes with signatures in the scan.dat, and it can be used to accurately detect malware and classify them. So this malware can be used for this uh, tool can be used for uh, classifying the malwares accurately. But yeah, it relies on the signatures present in scan.dat, and right now scan.dat has some limited number of signature. So now let me execute process memory scanner. It takes a bit of time to scan the processes. Let us wait till then. Okay, so it has detected the Ramcos RAT process. The binary of Ramcos RAT process is in this particular path. See sample Ramcos RAT, ramcosrat.exe, and its PID is 10804. So here is the PID you can see. So it has detected accurately this particular process and classified it as Ramcos RAT. Now, let us look into the third binary, that is third binary in the toolkit, that is injected code hunter. So injected code hunter has two binaries. One is injected code hunter x64 and x86. So basically these binaries can uh, detect injected code in the process and dump them to disk. So often you'll see that in the dumps, you will get unpacked binaries and injected code on which you can run static analysis or code analysis by uh, opening these dumps in tools like Ghidra. So it might not be always a proper P binary, uh, but sometimes it is going to help. Now, what I've done is I have put the injected code hunter inside another folder so that uh, so let me put that folder, and here I run injected code hunter. So here I'm going to run injected code hunter x86 because the Remcos RAT which I'm using is a 32-bit binary. So let me execute it. So you can see here that it just looks like the volatility dumps. There is a malfind plugin in volatility, so the output just looks very much similar. So you can see here it dumped some of the memory regions and showed its behavior also, like RWX is there. And uh, in the folder of code injection hunter, it has placed, it has dumped these binaries. And these binaries you can open in Ghidra or Bintext to see the strings. So one of the binaries I opened in Bintext, and if I see here, there are strings related to Ramcos RAT. You can see here, these are related to the Ramcos keylogger, and apart from that, Ramcos steal data from Chrome. Uh, and other places. So you can see all these strings here. And also one of the binaries which was dumped was a proper MZ binary. And I opened it in Ghidra. Even though you might not be able to debug the binary, at least you can see the strings there. If you want uh, a better dumping, you can use some other tools like process dumper tool, which has PD32 and PD64 to dump the binaries in a better manner and then analyze them. So this is all about the tool, process hunting toolkit, and you can use this tool for analyzing malwares. Also, you can use this tool for threat hunting as well. Thank you.